In this chapter, we're going to look at exponents and polynomials. So, I just want to start off with an example of what it means to be an exponent. Okay. Now, as you may remember from back in the day, this guy up here is called your exponent. But what is this thing called that it's attached to? It is x. This guy is a variable, but not everything that an exponent is attached to is a variable. Is it? No.
No.
It's called your base. It's called your base. Now, what does the exponent mean?
3 times 3 to the power.
Well, what does x to the third mean?
X times x.
Now, a lot of people will incorrectly say that it's x times itself 3 times, or some weird thing like that. What this means is that you have 3 factors of the base. This exponent tells you how many factors you have. So this guy, you see, is 3 factors. It contains 3 factors of the base x. When we talk about factors, we're talking about multiplication. So, in this problem, this example that I have here, the exponent of 3 that's attached to the base of x tells me how many factors I have of that base, how many times that factor shows up in the product. So we're talking about products, we're talking about multiplication, and when we talk about factors, we're talking about the pieces of the product, the pieces that make up the multiplication problem. So when I say these words, I need you to understand them so that you're not going to get confused. Now, what we do with these guys, one of the things that we do, is that we just evaluate. We can take expressions that contain exponents and we can evaluate them, especially if we understand how they expand. So if I want to evaluate 5 to the third, now notice I'm not solving this, I'm just going to evaluate. Okay? So when I evaluate 5 to the third, what does that mean?
5 times 5.
It means I see my factor of 5 how many times?
3.
So I have 3 factors of 5. And what happens when I multiply all of that together? 25 times 5, which is just 125. Do y'all agree? Okay. If I were to have this guy, 2 to the 5th power, what does that mean? So what you're saying is that I have 5
2.
factors of 2, right? So I have these 5 factors of 2. Now, if you want to use your hands on this, that's fine. So if I've got 5 factors of 2, but these 2 together, that's 4, right? And then times another 2, 8, 16, 32. Just make sure that all these guys get included. Just doubling that so you get x equals, or not x equals, there's another thing. Just solve for it. You just get 32. So far, so good? Don't you like to have negatives as well? Since I'm not looking at your faces, I'm going to assume that you are all nodding your head in agreement. So if I have negative 4 to the 3rd power.
There's 3 factors of the base, negative 4.
Thank you. 3 factors of my base, negative 4. So that's negative 4 times negative 4 times negative 4. Well, what's the sign going to be for this product? Right, and negative. Now that gives you 16. 16 times 4 is 64. Is everybody with me on that? Okay. Now I want you to compare some things because not every expression is exactly what you think it is. You have to pay very close attention to the exponents and their use in that particular example. So I want you guys to compare the following. Are these two expressions the same? Negative 5 squared versus negative 5 squared. They're the same? You think?
Mm-hmm.
It is.
I mean, it's the same, there's no parentheses around it, unless there was something else inside the parentheses.
Well, hold on here. This guy on the left, I think it's pretty clear that that's negative 5 times negative 5, right? And of course, that, because the square is applied to the negative 5, so you have two factors of the base negative 5. So that ends up as being a positive 25. Do y'all agree? What about negative 5 squared? Does it mean the same? Actually, it doesn't.
Mm-hmm.
With the way that this is written, what comes first? What are you doing to the 5 first? Are you squaring it, or are you multiplying times a negative? What comes first? The exponent takes precedence, right? So what this really means is that you have negative 5 times 5. That's what it really means. And so in this case, you get a negative 25. Now, the reason I point this out to you is because in your graphing calculator, or if you're using a two-line calculator, you need to make sure that what you're typing in is what you mean to type in. Because a lot of times students will type in negative 5 squared, and they expect to get a positive 25.
What about what we did up there with the 4? Would that have
Notice that the cube is on the whole thing of negative 4, right?
Mm-hmm.
So that's why the negative 4 is there 3 times. It's 3 factors.
Right.
Here, the square is applied. If I just have this, that's 25, right? Then you tack the negative onto it, so it's negative 25. Over here, the square is applied not just to the 5, but to the negative as well. It's applied to the whole thing.
Mm-hmm.
Any other questions about the difference here between these guys?